Morning everyone. Yeah, very good morning. Shall we begin the session? I'm fine. What about you? Yes, today's topic is the attributes. In the last class, we have started with the ER models and we have finished with the entity relationships. What is the meaning of entity? What is the relationship? Today's topic is the attributes. Yeah, we have discussed about the attributes, but not in detail, but in brief. What is the attribute? How it is used? That's all. But today I'm going to explain in detail why we require attributes, what are the usage of attributes, and how or what is the design phase that is available that is used in the attributes. So for each and every attribute, there is a set of the permitted values that is known as the domain or the value set of that attribute. For example, if I'm talking about the attribute person's ID that have a specific value that have a domain or the value set. And the domain of attribute course ID might be the set of all the text strings of a certain length. Similarly, the domain of attribute semester might be the string from the set, that may be a fall, that may be a winter, that may be a spring, that may be a summer. And formally, an attribute of an entity set is a function that maps from the entity set into the domain. And since an entity set may have several attributes, so each entity can be described by a set of the attribute data value pairs, one pair for each value of the entity set. For example, when we talk about a particular instructor entity that will be described by the set ID 76766, name Greek, department name biology, salary 72,000. That means that the entity describes a person named Greek whose instructor ID is this one and who is a member of the biology department with a salary of 72,000. So we can see it at this point that an integration of the instructor schema with the actual enterprise being used is known as the entity that constitutes a significant portion of the data stored in that database. And whenever we are using an attribute, I am using an attribute that is used in the ER model can be characterized by the following attribute types. One is a simple, one is a composite. So first point is simple and the composite attribute. So a simple means only one part. There is no sub part, there is no subdivision of that attribute. That is known as a simple attribute. Composite means that can be divided into sub parts. For example, when we talk about the attribute name, that can be that is a composite attribute. Because name is divided into sub parts like first name, middle name, last name. That is known as the composite attributes. When we talk about the simple attribute, that is known as the person ID or the employee ID, that cannot be divided into the multiple parts. That can be divided, but usually that cannot be divided. And using such attributes, using the composite attributes in a design schema is a good choice if a user will wish to refer to the entire attribute on the same occasion and only to a component of the attribute on that occasion on that subtle for which an address of an attribute address to the student entity set will be used. And the address can be defined as a composite attribute address with the attributes street, city, state, zip code. And this attribute helps us to group together related attributes, making the model clean or modeling the clean. Now, when I use the composite attribute that may appear as a hierarchy also in this one, address it's a component attribute street that can be further divided into street number, street name, apartment number. And this divides the example of the composite attributes for the restricted entity sets. Next one is the single valued and the multi-valued attributes. These examples have a single value for a particular entity. For example, when you talk about the student ID attribute for a specific student type entity that refers to only one student ID. Such attributes are said to be a single valued attribute. There may be instances where an attribute has a special set of the values for a specific entity. Suppose we add to the instructor entity set that may be assumed that may be used as a phone number attribute. Now these are the composite attributes: name, that is divided into the first name, middle name, last name; address, street, city, state, postal code. Again, street can be divided into the multiple parts: street number, street name, and apartment number. So when I talk about the address, that is a composite attribute, as well as the street, that is also a composite attribute. But sometimes they are known as, yeah, very good. That is known as a component attribute. Also, instructor may have a 0, 1, or several phone numbers, and different instructors may have different number of phones. So this type of attribute is also known as a multi-valued attribute. So as another example, we could add to the instructor entity set the attribute, that is the dependent name, that is listing all the dependents. And this could be multi-valued, since any particular instructor may have 0, 1, or 3 dependents. And to denote that an attribute is multi-valued, we use in the curly braces. Where appropriate, upper and the lower bound may be placed on the number of the values in a multi-valued attribute. For example, when I talk about the university, that will limit the number of phones of a number that record for a particular or for a single instructor to the 2. And placing the bounds in this case will be the phone number attribute of the instructor entity set that may have different or between 0 and the 2 values. Then the second part is the derived attribute. The value for this type of attribute can be derived from the values of any other related attribute or entity. For example, let's say that the instructor entity set have an attribute student advised, which represents how many students an instructor advises. How many students an instructor advises. So we can derive the value for this attribute by counting the number of students entities, 1, 2, 3, 4 entities that is associated with that instructor. So as with another example, suppose that the instructor entity set have an attribute age that indicates the instructor's age. This entity also have a different attribute like date of birth. So we can calculate the age from date of birth in the current day. Therefore, age is a derived attribute, and date of birth may be referred as a base attribute or a stored attribute. And this value of a derived attribute is not stored but is computed when it is required. This is known as a derived attribute. An attribute can also take a null value where entity does not have a value for it. A null value may indicate not applicable, that is the value that does not exist for the entity. For example, one may have no middle name. Null can also designate that an attribute value is unknown. An unknown value may be either missing, that may also exist, that we do not have information, or not known. For example, if the name value for a particular instructor is null. For example, that is not saying that every time it is null. If the name is null, then the value is missing, since every instructor must have a name. So a null value for the apartment number attribute could mean that the address does not include an apartment number, that an attribute or apartment number exists, but we do not know that what is missing up, and we do not know whether or not an apartment number is a part of the instructor address or not. That is also unknown. Unknown in the sense that is not known in the apartment number, that is not known in the instructor's address. Next one is the constraints. So any doubts anyone in the attributes? Anything that you want to ask? Yeah, there are two types. One is a derived, one is a multi-valued. Weak attribute is also a part of the derived attribute, basically. Now let's move to the next part, that is a constraint. In simple one, the conditions. So here interval schema may define certain constraints to which the contents of a database must conform. In this section, we examine mapping cardinality and the participation constraints. So first is a mapping cardinality, or the cardinality ratio, that expresses the number of entities to which another entity can be associated. That means how one entity is related with another entity via relationship set. that are more useful in describing the binary relationship sets, although they can also contribute to the description of the relationship set that involves more than two entity sets. But in this section, we only consider constraints on a binary set because this is in your syllabus. There's a binary relationship set, where the relationship set are between entity sets A and B. So mapping cardinality must be of the following. One is one-to-one, one-to-many, many-to-one, and many-to-many. So these are the various cardinalities. That is a mapping cardinality that shows the relationship. One-to-one means only one entity and another entity. There is a relationship between the one entity with the another entity. Then next one is one-to-many. So this is one is associated with the many entities. For example, when I talk about in the one-to-many, there is only one teacher, there are many students. So teacher is related to the many students, so more than one student. That is a one-to-many. One-to-one, only one teacher and the one student. That is a, yes, like a tuition. Only one teacher, one student, but that is not compulsory that there is only one teacher and the one student in the tuition. But when I talk about the personal attention that is given, so in this case, there is a one teacher, one student. Then next is the many-to-one. There are many entities that are related to the one entity. An entity in A is associated with at most one entity in the B, that is, however, is associated with any number. Then many-to-many, n number of entities related with the n number of entities or the many entity. That may be a 0 or 1, that may be associated with any number in the entity A. And the appropriate mapping cardinality for a particular relationship set obviously depends on the real world situation that the relationship set is modeling out. And as an example, consider the advisor relationship set. If in a particular university a student can be advised to only one instructor and an instructor can advise several students, then the relationship set from instructor to the student is one-to-many. And if a student can be advised by several instructors, as in the case, the relationship set is many-to-many. The next one is a participation constraints that is used in a relationship that is used or set R is set to be the total if every entity in E participates in at least one relationship in R. And if only some entities in E participates in the relationship in R, so this relationship that we say is a participation relationship that is used to be a partial. For example, when we expect every student entity to be related at least one instructor to the advisor relationship. Therefore, the participation set advisor is total, and in contrast, instructor needs not advise any other students. Hence, it is very possible that only some of the instructor entities are related to the student entity set through the advisor relation, and the participation of the instructor in the advisor relation set is therefore partial. The next one is the keys. So, any doubt in the constraints, anyone? Okay, just take 2 minutes for reading the constraints. Now let's start with the next concept, that is the keys. Keys in the sense, we can say the protocols or the tuples. That is a primary key, foreign key, super key, candidate key. These are the multiple keys. So in simple words, any entity that must be uniquely identifying the any value that must uniquely identify the entity, that is known as the keys. So we must have a way to specify how entities within a given entity sets are differentiable, and these entities are distinct from a database perspective. However, the differences among them must be expressed in terms of their attributes. So therefore, the values of the attribute value to the entity must be such that can uniquely identify the entity. And in other words, no two entities in an entity sets are allowed to have exactly the same value for that attribute for that entity set. And a notion of a key for a relation schema that must be defined, that must be applied to entity sets. That is the key for an entity, that is a set of the attribute that suffix to differentiate entities from each set. And the concepts of the super key, candidate key, and the primary key are applicable to entity set that are applicable to the relationship schema also. And these uniquely identifies the entity relationship, therefore that there is a distinguished relationship from each other. And keys also help to identify the relationships uniquely, therefore distinguish relationship from each other. So we define the notion of the keys and their relationship. This is the primary key, E1, union, primary key E2, till union, primary key N or En. That is A1, A2 till A. That describes an entity or individual entity set relationship in the set R. And in both of the above cases, the set of the attributes, whatever set that is given, that will be uniquely identified with the E1, E2, and till En. That forms a super key for that relationship set. And if the attribute name of a primary key are not unique, so if that is not a unique, that is the names are combined with the name of the attribute from which it is given a unique name, in that case it is also appears as the entity sets. That may be once in a relationship set, that may be a prerequisite relationship, and its all is used instead of the names of the entity sets to form a unique attribute name. So as an example, consider the entity sets instructor and the student and the relationship set advisor with an attribute date. In that case, there is a relationship set that is many to many. And the primary key of advisor consists of the union of the primary keys of the instructors and the student. And if that relationship is many to one, from the student to the instructor, that is, each student can have at most one advisor. Then the primary key of the advisor is simply the primary key of the student. That can advise only one student. That is, if the advisor relationship is many to one from the instructor to the student, then the primary key of the advisor is simply the primary key of the instructor. And for one-to-one relationship, either candidate key can be used as a primary key. And when we talk about the non-binary relationship, if there is no cardinality constraints are present, then the super key form that described earlier, that is only the candidate key, that is only the chosen as a primary key. Now next is how to remove the redundant attributes or the duplicate attributes in the entity sets. So we decided to include such entity set as a student, instructor, and once it is decided, we must choose the primary key attribute that is used with the attribute value, various values we want to capture in the database. And in the university example organization, we decided that for the instructor entity sets, we will include the instructor ID or attributes ID, name, department name, salary. So we could have added the attributes for number, office number, home page, etc. That is made up to the designer who have a good understanding of the structure of the enterprise. And once the entity and their corresponding attributes are chosen out, the relationship sets among the various entities are formed. And these entities or these relationship sets may result in a situation where attributes in the various entity sets are redundant and needs to be included from the original entity sets. The entity set instructor includes the attributes ID, name, department name, and the salary, with ID forming the primary key. An entity set department includes the attributes department name, building, with budget, with the department name forming the primary key. and that is used with the instructor department that is relating to the instructors and the department both. And since it is a primary key for entity set department, it is redundant in the entity set instructors that needs to be removed, that needs to be found with attribute from which the instructor may appear rather than unintuitive. And similarly, the student entity set is related to the department entity set through the relationship set student department. And therefore, there is no need for a department name attribute in a student. As another example, when we consider the course offering, that is the sections along with the time slots of the offering. So each time slot, whatever time slot that is identified by the time slot ID and associated with the set of the weekly meetings, is identified with the day of the week, start time, and end time. So we decide to model the set of the weekly meeting times as multi-valued composite attributes. With the entity sets, that may be a section, that may be a time slot ID. That includes attribute course ID, section ID, semester, year, building, room number, time slot ID with the course ID, section ID, year, semester that form in the primary key. It also includes attribute time slot ID, which is a primary key value and a multi-value composite attribute. Now these are the various primary keys: classroom with attributes, building, room number, and the capacity. Then department with attributes, department name, budget, building. Then course with attribute, course ID, title, credits. Instructor with attributes, ID, name, salary. Now these underlying attributes, that will be a building, room number from the classroom, that is we can set the primary key. Department name is primary key, course ID is primary key, normal ID of the instructor is primary key, section, course ID, section ID, semester year, both are the, or all are the primary key. Student ID is the primary key, time slot ID is the primary